Video lesson 13.3. We're going to be dealing with angle measures of arcs and the circles dealing with parallel lines within the circles. So there's two theorems that we should identify first, and that has to do with the parallel lines and the arcs that go along with them. So this first one here, right, we have that if we have two parallel lines, right, so in this case I've got these two parallel lines here, BC and DE. So if I have two parallel lines inside a circle, if those parallel lines are chords, they intercept the circle and have intercepted arcs. These two intercepted arcs that I'm highlighting here in pink are going to be congruent to each other. So these are automatically going to be equal. So whatever the measure of arc BD is, right? So BD, arc BD is going to be equal to CE, given that BC is parallel to DE. So it's a nice little property to have. It lets us kind of utilize the information and kind of help us, find pieces or things that I'm missing with a little bit of information. Again, you have to know that these are parallel, and again, they're showing that symbolically here with these little carrots symbols, all right, to show that those two things are parallel to each other. The other theorem has that if I have two congruent chords, so if AB here and CD are two chords, if those chords are equal in length, then their intercepted arcs are also going to be equal in length, right? One of the major ones here, so in this case, AB, arc AB, I should say, is equal to arc CD, all right, if the chords are in fact congruent to start with. One of the things that students have a tendency to kind of combine these two sentences together and these two theorems. Just because you have parallel lines does not mean that they are equal in length, right? Just be careful. It is possible that those parallel lines could be equal, and then yes, both of these theorems are happening simultaneously, right? But if you look at the first example here, right, it is not necessarily true that arc BC and arc DE here, that I've just kind of used the dotted lines in orange, those do not have to be equal. All right, now they may, if line segment BC and line segment DE are congruent, that would be the same thing that happened in the second theorem here. If those are in fact congruent, then yes, those would be equal arcs, but they do not have to be just because they're parallel. All right, and the same thing, just because they're congruent line segments within, or I should say congruent chords, does not mean that they have to be parallel. So again, they're two separate things. It is possible for them to happen at the same time, but is not a guarantee and does not have to be. All right, so let's look at some of these questions here and show a few examples, and then you can utilize practice problems for, to further the understanding. Feel free to at any time to pause the video, take any notes, or jot down anything that you need, or feel free to try it out on your own and come back and see if you did it right. All right, so this first example here, they're saying find the measure of arc CD and the arc ED. So in this particular case, I do notice, right, that I have two parallel lines. They're telling me here that these little carrots here are telling me that these two are parallel, right? So these are parallel lines. So I've got that information. So again, knowing that, that tells me that my two intercepted arcs here, so my arc BE and CD are going to be congruent to each other. So since, right, BC is parallel to ED, then we can conclude that BE, arc BE I should say, is equal to arc CD. So I'm trying to find the measure of CD. I'm looking here at what information I'm told. I'm told this angle is 65. And I say, okay, well, what kind of angle is that? Well, if I kind of trace the angle, I see that it does touch the circle with its two endpoints at B and E, and that the vertex is on the edge of the circle, so that makes this inscribed. So if this is an inscribed angle, that means it's half of its arc. So the other way of saying that is that the arc is 2 times the length of that angle. So BE, arc BE, is going to equal 2 times whatever the angle is. In this case, that's 65. And 2 times 65, that's 130 degrees. So we just found this one to be 130 degrees. We've also made the claim that BE and arc BE and arc CD are congruent to each other, so that makes this one 130 degrees also. So therefore, arc CD is 130 degrees. So that's our first part. The second part here asks me to find ED. So ED is this portion over here. Now again, I can't make that assumption that BC is equal to that because I have no indication that these line segments or these chords are congruent to each other. So that part's not going to be okay. If it was, I could say like call this X and then say X plus 130 plus X plus 130 all has to equal 360 degrees, which is possible. All right, but again, I'm not 100% sure at this moment that that is a guaranteed fact. So I can't just assume that from here. So we got to kind of get a little creative. So I'm looking at for other key parts here, and I'm noticing as I look at this that BD, right, that line segment right there is a diameter because it runs through the center of the circle. It's a chord that runs through the center. So since, I'll do that here, since AD is a diameter, right, then we know that arc BE plus arc ED has to equal 180 degrees because they would make this intercepted arc, which I'll do as a dotted line here, all the way around. That's half the way around the circle. So we already know that BE is 130. We're looking for ED, so I'm just going to call that X. So if I subtract this, I get X to be 50. Therefore, arc DE is 50 degrees. All right, so now I've just concluded this is 50 degrees. Now, coincidentally enough, like I said before, now we have enough information to actually prove that those two chords, BC and ED, are congruent to each other. Because if this is 130 and 50 on this side, notice that it's 130 and this other portion, BC, would end up being 50 also because this is the other side or other half of the circle. So that one ends up also being 50. So since these two segments now, since we know these two arcs, are congruent, then we can conclude that these segments are also congruent to each other. But again, that's not part of this question, but it is something that we were able to conclude from there. So it is something that could have been, followed up with or something like that. But we couldn't make that assumption at the beginning. It would have just literally been a guess, and that's not going to be enough for us to kind of go through it. All right, let's look at example number 2. Here, it's telling me that BC is parallel to AD, so I'm going to note that. So again, if I've got parallel lines, the intersecting arcs between those are congruent. So I've got BA and arc CD here. So I can now say that given this information, we know that arc BA is equal to arc CD. Again, arc BA or arc AB doesn't matter, same thing. And we're asked to find BC, which is this portion up here. All right. Well, they tell me that this one is 35, so AB is 35, so CD is also 35. And BC was what we're looking for, and I don't have a direct statement at the moment, but again, if I take a step back and I look for some important information, I see that AD is a diameter because it goes through O. Again, making all of this halfway around the circle. So I can then say that BC is going to be that BC plus the other two arcs here, the two orange ones, will have to all equal 180. So if I take 180 degrees and I subtract the portion that is orange, so in this case 35 plus 35, because that's the two pieces that we know, that's going to give me BC, which is what we're looking for. So I can simply now say that this is going to equal 180 degrees minus 35 plus 35 is 70. So arc BC is 110 degrees. So again, it's all about interpreting the information that I look for, see what information they give me, what type of other things could I get out of the picture and or the information provided. The second part is angle CBD. CBD. So I'm looking for this angle right here. So again, identify the type of angle that it is. So again, if I just kind of trace it, try to make it stand out a little bit, maybe it's easier to see. I notice I've got two endpoints on the circle and the vertex is also on the edge of the circle. So therefore that is an inscribed triangle. Inscribed angle. So that's going to be half of its intercepted arc, which in this case is arc CD, because that's where it intercepts right here. the distance between those 2 points, C and D. So we know CD already. We have that part. It's 35. So 1/2 of 35, that's going to get me 17.5 degrees for the angle measure. All right, let's look at example number 3. Again, they're told that BC and AD are parallel to each other. So these two are parallel. So once again, based on our original theorem, we know that the 2 arcs that are in between those 2 parallel lines, in this case AB again and CD, right? So we're going to now conclude that arc AB is equal to arc CD. Based on that information, I can make that assumption. That inference, I should say. And we're asked to find what the measure of CD is. So I'm looking for this. So I'm going to call it X. We also know that this is X. Then also, so we got to come up with a clever way of being able to figure out what this is. Once again, I don't know for sure if BC and AD are equal. If I knew for a fact that those are equal, then I can call this 100, right? Because then that would be the same arc as that. But I don't know that information, so I can't make that assumption right now. So I got to look for other things. I do notice here, though, I do have an angle, this 70-degree angle, and the type of angle, if I can identify it, right? If I trace it, sometimes it helps to see. Again, the vertex, is at the center of the circle. That makes this a central angle. All right, so just off to the side here, right? This is a central angle, and they are equal with their intercepted arcs. So that makes this here 70 degrees. So if this is 70 degrees, then we know that this is 70 degrees. So I'm going to say CD is equal to arc AB, which we already stated, which is 70 degrees. So there's my answer. Now it does ask me to find AD. So we can go find this portion here, right? So I'm going to have this part here. I'm not going to call it X because I already called X something else. So let's call it something, I don't know, let's say use Y. All right, so now I've got this information. So we know that this was 70, so I can also put this as 70 here. And now I do have information for all the arcs that make up the circle, right? So I do have an entire circle here. If I was to continue all the way around, right, I do get 360 degrees. So if I take 360 and I subtract all the arcs that I know, in this example, that's 70 plus the 100 that they told me, plus the other 70 that we found. So we're really going to have 360 minus, if I add these all up, that's 240, which concludes that arc AD is 120 degrees. So now I know that this is 120. So that's one way of being able to figure out what type of, the measure of that arc there, based on that information. All right. It also, again, we could follow up with a conclusion here, if it was asking me for, to prove maybe that BC and AD are equal or not equal or something like that, right? We now can state that they are not congruent, right, segments, because their intercepted arcs are not the same. So that would be a follow-up or something extra that you could do there. All right, last one for here, a little bit of a shorter video. In terms of question types and things. And that is this last one, and they give it to me in the form of a ratio. So I got two things here that I'm told. Arc CB, so this arc here, right, and ED, which is this one down here. First off, they're telling me that those two are equal to each other, so I can conclude that those are congruent. And then the other information that I'm told is that I've got here a ratio of information. So again, remember the ratio they write here is in the order that they stated here. So BC to, arc BC to arc BD to arc EC has a ratio of 2 to 3 to 5. So what I'm going to do here is I'm going to place an X next to each of them. We've done this in algebra when we're looking at the ratio of, maybe comparison of numbers, something like that, set them equal to a total. So I'm going to put a little X next to each of these because I want to represent exactly what the measure is. This is just the ratio. And once I figure out what the multiplier is, which is the X value, it'll tell me the actual measure. So so this first one is BC. So we're going to call this 2X. right? Next one is BD, which is over here. All right, so that's going to be 3x. We know that ED is the same as BC, so I'm going to call this one also 2x. And then the last one here is the 5, represents EC, which is over here. So I'm going to call this 5x. So now I've got all of my arcs that make up the circle. So I can go off to the side now and say, well, if I just add up all 4 of these arc values, which I have as algebraic expressions, they all have to equal 360 degrees. All right, so I can combine these. So if I add these all up, I get 12x is equal to 360. If I divide both sides by that 12, right, I'm going to get that to be, what is that, 30 for x. So x is 30 now. So now I can go back and replace each of these. So if x is 30, 2x would make this length 60. 3x makes 3 times 30, so that's going to make this arc 90 degrees. Again, we just did this one, that's 60 degrees. And then 5x is going to equal 150 degrees here. All right, so I now have each of those arc measures, which is going to allow me now to go and find each of these angles. So first angle is BCF. So BC to F is this one here. Now, if I extend this line, right, notice it does go to the circle, right? Doesn't change the size of the angle. I'm just extending the side of the angle, right? That makes this an inscribed angle to this arc over here. So that makes this one half of whatever BD is, arc BD. So half of 90 is going to give me my 45 here. Next one, I've got EDF. So again, trace E to D to F. Again, if I extend that, it goes to C. So I notice that this is also an inscribed angle. All right, inscribed to this intercepted arc over here. So this is going to be 1/2 of 150. What's that going to be? That's 75 degrees for that angle. And last but not least, we've got angle CFE. So CFE is this one here. So now we got to figure out what that angle measure is. Now, if it's a central angle, it would just be equal to this for that particular one. I don't know that one at the moment, if it definitely is, because they don't tell me the name of the circle. If they called it circle F, then I know that that would be the center, but I don't know that for sure. So we got to kind of go backwards here. So I'm going to plug in the information that we found. We know that this is 75, right? We found that this one was 45. Well, this angle here, this 45-degree angle intercepted this arc, which is the same as this angle, intercepts the same arc. So that makes this one also 45. And now, if you notice, the angle that we're looking for here, this CFE, this is an exterior angle to this triangle, which I'm going to highlight in yellow here. So this triangle, right, the angle we're looking for is an exterior angle to that. So exterior angle is just simply the sum of those remote interior angles. So 45 plus 75 would be equal to that angle. So I can just simply plug that in now and say, well, if I just add those two values together, that would give me my angle measure. In this particular case, we're saying 45 plus the 75, which would give me a total of, what is that, 120 degrees for that angle. Now, if you didn't catch that, you could have figured out what this angle is here and then say that the angle we're looking for is the supplement of that. If you did do this one here, right, you would have gotten this angle to be 60 degrees here, and then that obviously would have gotten me this one here, which is 120, which we just found. Again, whichever variation of that situation you like is fine. If you didn't recognize the exterior angle, it's okay. Exterior angle theorem is one of those ones that I feel like a lot of students kind of forget about. It does shorten and make things a lot easier in the long run, but if it's one that you missed, it's not the end of the world, because like I said, you could have just done 45 plus 75 plus what gives me 180, which is the yellow triangle, and then the supplement of that gives me the angle that I'm looking for, which in this case is angle CFE making it 120 degrees. All right. So again, as you go through, make sure you take an opportunity. If you have any trouble with anything, go back, relook it over. We'll be utilizing the practice problems for better understanding during our class.